Okay, we're going to be starting our year off by talking about matter and atoms. These are words you probably heard, and maybe you know the definitions, and maybe you don't, but by the end, you definitely will. So what exactly is matter? Matter is anything that has volume and that has mass. And when you say that something has a volume, all that means is that it takes up space. So when we say, like, oh, will you bring a 2 liter of soda to the club meeting? The 2 liters, that's the volume of soda. Okay? And mass is the amount of matter that an object has. And that's like kind of a weird definition. Like how much matter does something have? I don't know. A lot of people will say weight in exchange for mass, and they're kind of the same thing, but not quite. So imagine, for example, that you're a child genius and you're a NASA astronaut, and so you're at NASA, you're going to go to the moon, and so you step onto the scale, and it tells you that it weighs whatever, that you weigh 150 pounds. And then you step on the spaceship, you shuttle up to the moon, and you get there and you step off the spaceship and you take the exact same scale and you put it on the moon and you step on the scale and you do not still weigh 150 pounds. What? Why is that? Well, you still have your body, you still have your arms, you still have your legs, you still have your stomach, you still have all those things. So the amount of matter hasn't changed, your mass hasn't changed, but your weight has. Because weight is how hard gravity presses down on you. So that's where we get that little bit of difference, okay? So you'd weigh different weights on the moon or on Earth because the moon has 1/6 the gravity on Earth, so you would weigh 1/6 your weight on Earth. But your mass, your amount of matter that makes up your body, has not changed, okay? So not everything is matter, but most of the common everyday things that we think of are matter. So things like soccer balls, pencils, awesome lizards playing video games, those are all examples of matter. But light, heat, sound, thoughts, ideas, emotions, those are not matter, right? You can't put those on a scale. You can't bottle them up, okay? Not matter. So then if we're thinking about an atom, which is the word I'm sure you've heard, basically an atom is the smallest building block of matter. And matter is anything that has mass and takes up space, okay? It's the smallest building block. And so if we're looking at this little Lego house right here, basically an atom would be one of those individual little blocks, okay? And then the whole house is what we make out of that. So now we're going to learn about the parts of the atom. Now, you might be going, wait, what? You just told me that an atom is the smallest building block of matter, so how can it have parts? Well, as it turns out, even an atom is made up of little parts, just like how your body is made up of parts, right? And so here are the parts of an atom. There's the center of the atom, okay, that's called the nucleus, and there are 2 smaller particles in there. They're called protons and neutrons, okay? Protons have a positive charge. Typically, if you're pro something, you like it, so pro-positive. And neutrons have no charge. The other way that they're said is they're neutral. Neutrons are neutral, no charge. Protons are positive, plus charge. Okay, so that's in the middle, in the core. And then surrounding the nucleus on the outside is what we call like a cloud of little teeny tiny particles, way, way, way smaller than an atom, way, way, way smaller than protons and neutrons, are electrons. Okay? And electrons have a negative charge. And you might think, electrons, that sounds like electricity. It sure does, and guess what electricity is? Just a whole bunch of electrons moving around. Kind of cool. So anyway, we've got the big protons and neutrons, I mean big compared to an atom. We've got those in the center, and we've got teeny tiny electrons kind of zooming around the outside of the nucleus, around the center, and it's kind of like in a cloud or like in a swarm of bees, whatever visual makes sense. They're just kind of all around that center nucleus. Here's a model of a helium atom, like helium balloons, like those party balloons. And here we see in red are 2 positive protons. Here are 2 neutral neutrons. I know that because there's no charge inside of them. And then here on the outside are the 2 electrons. Notice they're drawn in a circle. Atoms are typically drawn that way because it's hard to draw like a cloud, right? But know that they don't go in these beautiful, perfect circles around the outside. It's much more chaotic than that, okay? But that's what a helium atom looks like. So I just told you that there were 2 protons and 2 neutrons and 2 electrons in an atom of helium. But how did I know that? How can I figure that out? Well, in order to figure out the number of protons, neutrons, and electrons that any atom has, we can turn to our good friend. It's going to become your best friend in chemistry, the periodic table. Hopefully you've seen one of these before. If not, you're going to get used to looking at it a lot here in our class time together. Each element has a different square on the periodic table, and we're going to now take a look at what information can be found on each individual square. So in the square, one of the things you'll notice is they all have a symbol, and that symbol right here for carbon is a C. It's a 1 or 2 letter symbol. If it's 2 letters, the first letter is uppercase and the second letter is lowercase. If it's 1 letter, then it's just uppercase, okay? And that just abbreviates the name. So C for carbon, that makes sense. A lot of them make sense, but some of them don't. Some of the abbreviations don't make sense, but that's because a lot of these things were named based off of like Latin or other languages, and English was not the first language these things were named in. And so the English translation makes it a little bit weirder, but basically it comes from their Latin names, okay? In all of your periodic tables, it's the upper right or the middle or the upper left, somewhere on the top, and this one happens to be the left. There's what's called the atomic number, and this is really important. Your atomic number is always equal to the number of protons in that atom. And that is a defining characteristic of an atom, the number of protons it has, okay? So carbon's number 6, so it has 6 protons, okay? The other thing down below here is the average atomic mass, or what we call the mass number. This mass number right here, 12.011, is equal to the number of protons and the number of neutrons. So if you add them up, protons plus neutrons, you get your mass number, okay? So that's what your box on the periodic table can show you. So let's go back now to that helium atom, and let's take a look at helium's square on the periodic table. Here's the symbol He, named helium, somewhere at the top, and as it turns out for this one, it's the upper left. There's my atomic number, and look back at your notes. Your atomic number is equal to what? The number of protons. Yes, yes, yes. All right, so there are my 2 protons for the atomic number 2. Now, my mass number down here is equal to my protons plus my neutrons. And always we're going to round this number to the nearest whole number. In a later lecture, we'll talk about why this is a decimal, but we're not going to deal with that right now. So if we round this off to the nearest whole number, that would be 4. Okay. So we know we have 2 protons, and our protons plus neutrons equals 4. So 2 plus what equals 4? 2, right? The other way you can think about it is you can do your mass minus your protons. Your mass minus your number equals neutrons. 4 minus 2 is 2. Okay, either way we get 2 neutrons. Okay, and what about electrons? For right now, this will change, but for right now we're going to say that protons equal electrons. Okay, so if I have 2 protons, I have 2 electrons. So there you go. Let's try one more practice. How many protons, neutrons, and electrons does an atom of boron have? Okay, well, let's start with the easy one. Protons, number of protons is always equal to the atomic number. Here's my atomic number 5. So it's got 5 protons. What about neutrons now? Well, protons plus neutrons equals my number down here, my mass number. I'm going to round this off to the nearest whole number, which is 11. Okay, so 5 plus what is 11? 5 plus 6, right? The other way to think of it is 11 minus 5 is 6. Either way, we get to the fact that there is going to be 6 neutrons in this element. And we also know that our number of electrons is going to equal our number of protons. And since we have 5 protons, we have 5 electrons. Okay, so here's a picture just to confirm. Here's our 1, 2, 3, 4, 5 protons. Here's our 1, 2, 3, 4, 5, 6 gray neutrons. And here are 5 electrons around the outside. So notice with helium, it was 2, 2, and 2. And with boron, the numbers weren't all the same. Sometimes they'll match, sometimes they won't. And that's okay. You just got to do the math. So here are the main points, the main things that we learned in this lecture. And hopefully, if you've been paying attention and taking good notes, you now know all of these things.